You as a student have a unique ID. Each ID for each student at school is different. With that ID number, I can identify which student it belongs to. Just like your ID number, quantum numbers are unique to each electron. It identifies each electron by a set of numbers. Quantum number describes the electrons in an atom. It gives you the probability of where the energy, the location, or the momentum of the electron is. However, you could only know the probability of one of the three. You cannot know all three, energy, location, and momentum at the same time. To identify an electron, you will use 4 different quantum numbers. The first of the quantum numbers is the principal quantum number. Its abbreviation is N. It measures the orbital size or the energy level. So it is known as the energy level or energy shells. It pretty much matches the periods. Remember, periods go across, so horizontal, left to right, of the periodic table. Right now, there are 7 periods in the periodic table. So there are 7 energy levels or shell. If we discover more elements, it could go up to infinity. To determine the number of electrons in the principal quantum number, the basic formula is 2 times the N, which is the energy level or shell, squared. Unlike the Bohr's model, the current theory states there's a probability of finding an electron in the electron cloud. One of the shapes of the electron cloud is a sphere. So if it's at the energy level 1, which is N is equal to 1, it is closer to the nucleus, so the sphere is smaller. As we go to energy level 2, N equals to 2, since it's further away from the nucleus, the electron cloud is larger. And as we move to energy level 3, which is even further away from the nucleus, the electron cloud is even larger. So in general, the size of the electron cloud increases as distance increases from the nucleus. 7 energy levels, N equals 7, will have the biggest energy cloud. So if we look back at the Bohr model, if the green is the nucleus, the first ring is energy level 1 or N is equal to 1. There are 2 electrons maximum possible in energy level 1. The second ring is N is equal to 2. It has 8 electrons maximum. The third ring is N is equal to 3 and it's 18 electrons. N equals 4, energy level 4 is 32 electrons. Energy 5, 6, 7 levels will also have 32 electrons. But as we discover more atoms, these numbers will change. Right now, this is the Bohr model. In the next video, I will show you how exactly they fill in based on quantum numbers. Angular momentum quantum number, L, is the second quantum number. It gives the shape of the wave, and there are different orbital shapes and sizes. These are also known as sub-energy levels or sub-energy shells. So that means within each principal quantum number or N energy level, there are sub-energy level within it. The general formula for angular momentum is L is equal to N minus 1. So that means L can equal to 0, 1, 2, up to infinity minus 1. N is equal to 1. L is equal to N minus 1. So this is 1 minus 1. So L is equal to 0. If N is equal to 4, L is N minus 1. So this is going to be 4 minus 1. So L is 3. However, when L is equal to 3, it must have a 2, a 1, and a 0. So each energy level must have, in order to have sub-energy level 3, n equals 4 must also have 2, 1, and 0, because 3 is the highest sub-energy level. To have the highest sub-energy level, you must have all the preceding lower sub-energy level. The total orbital number, L subshell, is equal to 2L plus 1. As we stated in the previous slide, angular momentum is the shape of the orbital. So we know that L can have values of 0, 1, 2, 3, up to infinity minus 1, depending on the energy level. When the value of L is equal to 0, the shape of the orbital is S. The electron cloud that represents S is a sphere. When L has a value of 1, the shape of the orbital is P. Its electron cloud looks like a dumbbell. When L has a value of 2, the shape of the orbital is D, and it looks like 2 dumbbells put together. So you could think of 2 P's put together. When L equals to 3, the shape of the orbital is F. The electron cloud looks like 2 D's put together. If we discover more elements in the future, we could also have L value of 4. When L value of 4, the shape of the orbital is going to be in alphabetical order. So after F, it's going to be G. So when L equals to 5, the shape of the orbital will be H. After L equals 3, we just go in alphabetical order. The third quantum number is called magnetic quantum number, which is M subscript L. This determines the orientation in space. Since we live in a 3D world, we're going to use the X, Y, Z plane. The general formula for ML, or magnetic quantum number, is plus or minus L, which is the angular momentum. From the previous slide, we know when L has a value of 0, its orbital shape is S, and the electron cloud looks like a sphere. Since we live in a 3D world, when I rotate the sphere, no matter how I rotate it, it's going to look the same. So it's only going to have one orientation in space. So when I calculate my value for my orientation in space, or magnetic quantum number, ML is going to equal to plus or minus L. When L equals to 0, this is going to equal to 0. So ML only has one value, which is 0. Since there is 1, there is only one orientation in space. When L is equal to 1, we said the orbital shape is a P. In the previous slide, we said it was a dumbbell shape. So when we calculate ML, this is going to equal to plus or minus L. Since L equals 1, this is going to equal to plus or minus 1. So my values possible is plus 1, and since it's a range, it could be 0 and minus 1. So if you notice, there are 3 orientation in space, and that makes sense. Because it's a dumbbell, it could lie in the Y, X, and Z plane. When L is equal to 2, that is a D. ML, again, is still plus or minus L. This is going to equal to plus or minus 2. And so my range is going to be plus 2, plus 1, 0, minus 1, minus 2. And so if you notice, there are 5 different orientation, and so there's 5. And so we stated the D looks like 2 P's put together. They could go in the XY plane, the YZ plane, and so forth. And then the 5th one is a P orbital with like a donut around it. When L is equal to 3, we know the shape is going to be F. So ML is equal to plus or minus L, which is equal to plus or minus 3. So my range is plus 3, plus 2, plus 1, 0, minus 1, minus 2, minus 3. So there are 7 possible orientation for F. Most of them will look like this one in the XY plane and so forth. It's pretty much 2Ds put together. And then you're going to have one that is a P orbital with a donut on the top. and a donut on the bottom. These drawings are better online, or you could find them in your book. So magnetic quantum number just tells you how they are orientated in space. Each orientation in space counts as one magnetic quantum number. So this table just summarizes the previous slide. When L equals to 0, the shape of the orbital is S, and only one possible orientation, so it's a 0. So the number of orbitals is 1. When L equals to 2, the shape is a P, and again, ML is equal to plus or minus L. So it's going to be 1, 0, and minus 1. So there are 3 possible orientation or orbitals. When L equals to 2, shape of the orbital is D, plus or minus 2. So it's 2, 1, 0, minus 1, minus 2. So there are 5 total orbitals. When L equals to 3, it is F. So it's positive 3, positive 2, positive 1, 0, minus 1, minus 2, minus 3. So there are 7 possible orientation. So there's 7 orbitals. When L equals to 4, it is G. So it's 4, 3, 2, 1, 0, minus 1, minus 2, minus 3, minus 4. And so there are 9. So if L equals to 5, remember it's the next letter in the alphabet. So this is going to be H. So this is going to be plus or minus 5, 4, 3, 2, 1, 0, minus 1, minus 2, minus 3, minus 4, minus 5, and so forth. And so there are 11. If you notice, the number of orbitals increases by every odd number. The last of the quantum number is called the spin magnetic quantum number, M subscript S. It gives the direction of the spin. Electrons are in an orbit. They spin either clockwise or counterclockwise. So MS can have 2 values. It could be plus or minus 1/2. So if it spins one way, it's going to be plus 1/2. If it spins in the opposite way, it's a negative 1/2. And the last thing, each orbital can hold a maximum of 2 electrons, and they must spin in the opposite direction. So let's look at this first example, the number of electrons possible for the following quantum number. When N is equal to 3, L is equal to 0. So that means ML is going to equal to plus or minus 0. So the only value for ML is 0. This is one orbital or one orientation in space. Each orbital can hold a maximum of 2 electrons. Since there is one orbital, this one will have only 2 electrons. So pause the video, try the next 3, and then check your answer. So N equals to 3, L is equal to 2. So ML is going to equal to plus 2, plus 1, 0, minus 1, minus 2. Because ML is equal to plus or minus L, which is equal to plus or minus 2. And remember, it's the entire range. ML represents the orbital or orientation in space. This one has 5. 1, 2, 3, 4, 5. Each orbital can only hold a maximum of 2 electrons. So this is 10 electrons. This one, C, N is equal to 3, L is equal to 2. ML is given as negative 1. So there is only one orbital. So this one can only have a maximum of 2 electrons. D, N equals to 5, L is equal to 0, ML is equal to 2, MS is equal to negative 1/2. This is no electron. It's not going to be possible. The reason it is not possible is because ML is incorrect. If L is equal to 0, ML is equal to plus or minus 0, so it has to be 0. It can't be 2. No electrons exist. The other way I could correct this is if ML is equal to 2, L can equal to 2, 3, or 4, but it cannot equal to 5. Why? L is equal to N minus 1. Since N is 5, 5 minus 1 is 4. So you can have 2, 3, or 4. You cannot have 5, a 1, or a 0. So D is not possible. Pause the video and try these problems on your own and then check your answer. So here we're going to determine if the quantum numbers are possible. If it's not possible, we're going to correct it. And we're going to ID the corresponding orbitals. So when n is equal to 3, L is n minus 1. So this is possible because 3 minus 1 can be 2, 1, or 0. ML, remember, is the orientation in space, so it's plus or minus L. Since L is 2, plus minus 2 also includes 1, so this is correct. MS can be plus a half or minus a half. It doesn't matter which one you use for the class. You just need to use one or the other. A is correct. So the corresponding orbital is going to be energy level 3. L is equal to 2 is D. So this is 3D. Next one, when n is equal to 5, L can equal to 0 because L is n minus 1. So 5 minus 1 can be 4, 3, 2, 1, 0. Remember the S before you can have a P. To have a D, you must have a S and a P first. To have a F, you need a SPDF. So L equal to 0 is correct. ML is equal to 1 is not correct. Since L is equal to 0, ML can only be 0 because it's plus or minus 0. So this one is not possible. To correct it, ML must equal to 0. Identify the orbital. This is energy level 5. A 0 is an S, so it's 5S. For C, n is equal to 4. L is incorrect. L is equal to n minus 1. So 4 minus 1 can be 3, 2, 1, 0. So 4 is not correct. So I could put 3 to correct this, because if I make L is equal to 3, ML can be 3, because ML is equal, which is plus or minus 3. So plus 3, plus 2, plus 1, 0, minus 1, minus 2, minus 3. And MS is minus 1/2, or it could be plus 1/2. So this one is energy level 4. 3 is an F, so it's 4F. D, when n is equal to 2, L is equal to 1. That is possible because L is equal to 2 minus 1. So it's going to be 1 or 0. ML is plus or minus 1 because L is 1. So it could be plus 1, 0, or minus 1. And MS could be a negative 1/2, so that is correct. So this is energy level 2. 1 is P. E, when n is equal to 1, L can be 0. Well, L can only be 0 because 1 minus 1 is 0. ML is plus or minus 0, so this is correct. However, this is wrong. It cannot be plus 1. It could be a plus 1/2, or you could put negative 1/2. Identification of the corresponding orbital. N is equal to 1, so we're at energy level 1. 0 as S, so it's 1S. F, n is equal to 6. L is equal to 5. That is possible. 6 minus 1 is 5. So if L is 5, you must also have 4, 3, 2, 1, 0. Since L is equal to 5, ML is going to be plus or minus 5. So it's going to be plus 5, plus 4, plus 3, plus 2, plus 1, 0. Minus 1, minus 2, minus 3, minus 4, minus 5. Since minus 2 is part of that, that is correct. And my spin is correct. My orbital is 6 and 5 is H. Pause the video and try these problems on your own and then check your answer. So determine the number of orbitals and electrons. So orbitals are orientations in space. So orbitals is magnetic quantum number, which is ML, which is going to be plus or minus L. And we know that L is equal to n minus 1. When n is equal to 2, L can equal to 0 or it could equal to 1, because 2 minus 1 is 1 and 0. And remember, we must have a 0 or an S before we can have a P. We must have a S and a P before a D. So ML is plus or minus L. So for 0, it's going to be 0. For 1, it's going to be plus 1, 0, and minus 1. So there's a total of 4 orbitals. Each orbital can have a maximum of 2 electrons. So that means 4 times 2. So there's going to be 8 electrons total. When n equals 3, L is equal to 2. That is possible because 3 minus 1 is 2. It could also be 1 and it could also be 0. ML is going to be plus or minus L. So for L is equal to 2, it could be plus 2 plus 1, 0, minus 1, minus 2. And since it's 1, there's only one orbital. Since they gave you a spin, there's only one total electron. The spin can be up or down. When n equals to 5, here L is equal to 0, and that is possible because when n is equal to 5, we could have L that is equal to 4, 3, 2, 1, and 0. Since L is equal to 0, we know ML has to equal to 0 because it's plus or minus L. Since there's only one orbital, this is going to have 2 electrons. When n is equal to 4, L can be 3, 2, 1, or 0 because n minus 1. Since L is equal to 3, that's going to be plus or minus 3. So that's plus 3, plus 2, plus 1, 0, minus 1, minus 2, minus 3. So there's 1, 2, 3, 4, 5, 6, 7 orbitals. So there's going to be 14 electrons here. When n is equal to 2, L can equal to 1 or 0. Since it's equal to 1, ML can be plus or minus 1, so it's going to be plus 1, 0, minus 1. Since it's 0, that's one orbital. Since they gave you the magnetic spin, and it's a minus 1/2, this can only have one electron. When n equals to 1, L can only equal to 0, because 1 minus 1 is 0. Plus or minus 0 is 0, so there's one orbital, and so it's going to have 2 electrons. When n is equal to 6, L could equal to 5, 4, 3, 2, 1, 0, but they gave us L is equal to 5, so ML could be plus or minus 5, so it could be plus 5, plus 4, plus 3, plus 2, plus 1, 0, minus 1, minus 2, minus 3, minus 4, minus 5. Since they only gave us one of the orbitals, there's only one orbital which will hold 2 electrons. If you notice, as we go to the right, it gets more restrictive, and so it's going to have less electrons. As we go towards the left, which is N is less restrictive. So MS is the most restrictive, then ML, L, and then N.